So we just wrote the partition helpers routine, and we used the cross product of type comments tables to help us write this routine. And now we want to test our function to see if it works out. So that's where we're going to start, and let's test the function. So it's, so let's run our. Well, I need to learn how to spell partition problem, Python 3 partition problem. We're going to run the test. Ooh, and we have failure. Our tests fail. So we did all this analysis, and we got all these cases, and we had this map, and our map was supposed to tell us what to do, and it's sort of failing. So what's going on here? So we have to look at our examples to figure out what's happening. So if we look at the code, the failed test, and if we look at the partition helper failed test, so it tried to run the first test, and then it says it's starting to have problems at this partition, the case where the target's greater than 0, and also when we're in the middle of the array. So let's kind of look into that case. So if we go to line 58 in our code in the test, and we try to run it through our head and see what happens. So suppose we take 5 as we take 5 into our subset. So now our target value is 6. And we go to the next set of numbers. We hit 11, and we still have 5 and 1 to go. And so our target value is 6, and we have to decide whether to take 11 or not into our subset. So as we can see in line 51, what we're doing is we're actually we're trying to see what happens if you take it and if you don't take it. So if you take the 11, then what's happening is that we have this first part right here of line 51 that is going to deal with that case. So what's happening here? So target, which is 6, and the array value, because we're at the 11, what happens is target minus array value at index I is negative. So 6 minus 11 is minus 5. So what's happening is we're running this recursive call is going to call itself with a target value of negative 5. And what we see here is that we have not designed any case to deal with that. So even though we have this type comment with target is 1 of 0 or natural number, we see that there's this case. The way the computer runs, we have this case where our target is becoming a negative number. And we have to deal with that. And so this is because the way the code runs, the way that, because we're trying everything. So like these types of functions are sort of like organized brute force. You try everything. And so you're trying this negative value when it shouldn't. So our map that we're talking about, this product table, it's getting us most of the way there. But our experience walking, we'll notice that something's slightly not right, and we're going to have to fix that. And so our test is kind of like walking through the place. We kind of find out if there's any slight things wrong in the map. So given that, we have to fix this. So we can easily fix this. So we can say in this fourth box, which is what's happening in line 50, so if array i's value, so that's like the 11, is greater than the target, then I don't want to do this first recursive call here. I only want to do the second one. So let's copy that. So we need to return it. And then else, in this case, if the target value stays positive, essentially, then we return both. We try both things, and we see if these smaller dominoes for smaller problems in line 54 help us knock down our bigger problem, which is the whole array. So if we do that, and we now run our test, okay, so can partition. Okay, so this error is actually due to my misspelling mistake. So this is one of those things I talked about earlier, is making sure your tests are well formed. And one thing that happened was that it wasn't well formed, and this is kind of my fault, and kind of because I wasn't thinking in terms of Python. In Python, you only it doesn't necessarily run all your tests or check all your tests, and versus in other languages such as Racket, which is a dialect of Lisp, they check all your tests when you originally run stuff. So let's see if that mistake solves our problem, if that spelling mistake solves our problem. And so we ran it right here, and it says ran 2 tests in 0 seconds, and we're okay. So that means all our tests pass. So all our tests pass. So what just happened? So what we just did is we took a function. We had this complicated problem where we had to divide things into 2 subsets and to see if we can get them to be equal to each other. We took that. We used a method to think about how to break our problem into subproblems by deciding what to do with this last element. So in a sense, like if you look at line 61, we had to decide whether we were going to take the last 5 on the right in our subset or not take it in our subset. So we had this pick and choose. Then what we did was we let our data, which is modeled by our type comments, lead us to the design of the function. And so now we have this partition helper function that solves our problem. And so we've done this, but in the next video, what I'm going to talk about is that there's some optimizations that need to be done, because what you'll notice is that these partition subroutine actually sometimes calls the same recursive call multiple times. And we don't usually need to run a recursive call multiple times. We could just save that recursive call and run it again. And this will save space, and it will help us save time as well. By space, I mean that it doesn't cause our recursive stack to overflow. So in the next video, we're going to talk about that.